Good morning, learners and viewers. Welcome to the session for Management Information Systems, MMPO 004. Today we will be discussing about Unit 9 that is related to DBMS implementation and future trends. With the advent of cloud computing, the market for database systems has shifted towards cloud-based solutions. Cloud-based DBMS solutions offer many advantages over on-premises solutions such as scalability, flexibility, and reduced infrastructure cost. Cloud-based solution also offers the ability to easily integrate with other cloud-based services such as analytics and machine learning tools, which can help organizations gain insights from their data more quickly and efficiently. Another advantage of cloud-based DBMS solution is that they often come with built-in security features such as encryption and multi-factor authentication, which can help to protect sensitive data. Despite the advantages of cloud-based DBMS solutions, there are still some organizations that prefer to use on-premises solutions due to concern about data security, compliance, and control. In response to this, many DBMS vendors are now offering hybrid solutions, which combine on-premises and cloud-based solutions to provide organizations with best of both the worlds. Legacy system can pose several challenges for organizations, such as security, vulnerabilities, difficulty integrating with newer technologies, and the cost of maintaining outdated hardware and softwares. Despite these challenges, many organizations continue to use legacy systems due to their business critical nature, cost effectiveness, or simply because they work well and there are no pressing needs to change them. The challenges posed by legacy systems, organizations can take a variety of approaches such as modernization, migration, or retirement. Modernization involves updating the software or hardware components of a legacy system to improve its functionality and maintainability. Secondly, migration involves moving data and applications from legacy system to a newer one. And thirdly, retirement. This involves decommissioning a legacy system and transitioning to a new altogether. DMMS are changing, however, they are expanding, taking on more responsibilities, and providing smarter answers. As new goals and problems present themselves, the desire to find new ways to use database management prompt unique solutions. Standards are very important for application development, especially in the age of internet, since applications need to communicate with each other to perform useful tasks. A variety of standards have been proposed that affect database application development. Electronic commerce, what we call it as e-commerce, is becoming an integral part of how we purchase goods and services, and database plays an important role in that domain. Web interfaces to database. The web has become important as a front end to databases for several reasons. Web browsers provide a universal front end to information supplied by backends located anywhere in the world. The front end can run on any computer system, and there is no need for a user to download any special purpose software to access information. Today, almost everyone can afford it has access to the with the growth of information services and electronic commerce on the web. Databases used for information services, decision support, and transaction processing must be linked with the web. Web interfaces to databases allows user to interact with and manipulate data stored in a database through a web browser. Some common types of web interfaces to databases are web forms. Web form allows users to input data into a database through a web browser. They can be used for tasks such as data entry, surveys, or online orders. Secondly, reporting interfaces. Reporting interfaces allows user to query and retrieve data from a database and display the result in a user-friendly format, such as a chart, graph, or a table. Dashboard interfaces. Dashboard interfaces provide an overview of data in a database, often using visualizations such as charts and graphs to display key matrices and trends. Fourth one is mobile interface. Mobile interface provides access to a database through a mobile device, such as a smartphone or tablet. They can be designed to be responsive and mobile friendly, making it easy for users to access data on the go. Web interfaces to databases can be integrated with various web technologies such as HTML, CSS, JavaScript, and Ajax. They can also be integrated with server-side technologies such as PHP, Python, Ruby, and Java to provide dynamic functionality and database connectivity. Web interfaces to databases are essential for many organizations as they allow users to access and manipulate data without the need of specialized software or technical expertise. Web provides a way to integrate multimedia content and other resources into database application. For example, a database application for a museum could include multimedia content such as images, videos, and audio recordings to enhance the user experience. Another important aspect of web is its ability to provide real-time access to the data. This means that users can access and interact with data in real time rather than waiting for data to be processed and returned to them. This is particularly important for applications such as financial transactions and real-time monitoring systems. The web provides a way to easily distribute database applications to a large number of users. With the use of cloud-based technologies, organizations can deploy their database application to a large number of users without having to worry about managing the hardware and software infrastructure. Programs can be written in client-side scripting languages such as JavaScript or can be applets written in the Java language. A web server is a program running on the server machine which accepts requests from the web browser and sends back the result in the form of HTML documents. The browser and web server communicates by a protocol called Hypertext Transfer Protocol, what we call it as HTTP. HTTP provides powerful features beyond the simple transfer of documents. The most important feature is the ability to execute programs with arguments supplied by the user and deliver the result back in the HTML document. A new service can be created by creating and installing an application program that provides the service. The Common Gateway Interface, that is CGI, standard defines how the web server communicates with application programs. The application programs typically communicates with the database server through ODBC, JDBC, or other protocols in order to get or store data. CGI, which is Common Gateway Interface, is a standard for interfacing external applications with web servers to generate dynamic web content. CGI scripts are used to enable web servers to execute programs or scripts which can generate dynamic content, such as web pages or other multimedia content. CGI scripts can be written in many different programming languages, such as Perl, Python, and PHP. ODBC, this stands for Open Database Connectivity. It is a standard interface for accessing database management system developed by Microsoft. ODBC provides a common language for communication between applications and DBMS, allowing different applications to access data stored in various DBMS using a common set of functions. This enables developers to write database applications that can work with different DBMS without having to rewrite the application code each time. ODBC drivers are available for most popular DBMS such as Oracle, SQL Server, MySQL, and PostgreSQL, making it widely used interface in the industry. Second one is JDBC. This stands for Java Database Connectivity. It is a standard API for accessing and manipulating relational databases. JDBC allows Java program to interact with a wide range of DMS such as Oracle, SQL, MySQL, or and PostgreSQL without having to use DBMS specific APIs. This JDBC provides a set of interfaces and classes that enable Java programs to perform common database operations such as connecting to a database, executing SQL queries and updates, retrieving results, and managing transactions. Specialty database. Specialty databases are databases which are designed to handle specific type of data or specialized application. Some examples of specialty databases includes Geographic Information System, that is GIS databases. These databases are designed to store, retrieve, and analyze spatial data such as maps and satellite images. Time series databases. These databases are optimized for storing and querying time series data such as stock prices, weather data, and sensor data. Third one is graph databases. These databases are designed to store and query graph structures such as social network and recommendation engines. Document-oriented databases. These databases are optimized for storing and querying semi-structured and unstructured data, such as text documents and multimedia contents. In-memory databases. These databases store data in memory instead of on disk, allowing for faster access and processing the data. Real-time databases. These databases are designed to handle high-speed, low-latency applications such as financial trading systems and gaming platforms. Each type of specialty database has its own unique set of features and capabilities, making it well suited for specific type of applications and use cases. Big data. This refers to the large, complex data sets that cannot be easily managed or processed by traditional database management systems. Big data solutions typically involve distributed computing technologies that allows for parallel processing of data across many servers as well as specialized tools and algorithms for data analysis and machine learning. Big data is often characterized by three V's: volume, velocity, and variety. As far as volume is concerned, refers to the sheer size of the data. This velocity refers to the speed at which data is generated and needs to be processed. And thirdly, variety, this refers to the different forms and structure of data. To handle big data, specialized tools and technologies are needed, such as distributed computing systems like Hadoop and Spark, NoSQL databases, and data warehouses. These technologies allow for the processing and analysis of large, complex datasets to extract valuable insights and knowledge. Another trend in database management is the use of NoSQL SQL databases. Now, what is meant by NoSQL databases? These are non-relational and are designed to handle unstructured or semi-structured data such as social media data or sensor data from the Internet of Things, that is IoT. NoSQL databases use different models that traditional relational databases such as key value, document oriented, or graph databases. Some example of popular NoSQL databases includes MongoDB, Cassandra, Couchbase, and Amazon DynamoDB. These databases are often used in big data application, real-time data processing, content management, and other data-intensive applications where scalability, flexibility, and performance are critical. Database management systems are increasingly being integrated with other technologies such as cloud computing and artificial intelligence. Cloud-based database solution allows for scalable and flexible data storage and processing, while artificial intelligence tools can be used to automate tasks such as data cleaning, classification, and analysis. Artificial intelligence refers to the development of computer systems that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision making, and natural language processing. Artificial systems use techniques such as machine learning, deep learning, and neural network to analyze data, recognize pattern, and make decisions based on that data. These systems can be used to automate and optimize a wide range of processes from customer service to medical diagnosis, and they have the potential to revolutionize the way we live and work. XML, that is Extensible Markup Language, was initially designed as a way to add structured information to text documents. It has since become widely used as a format for exchanging data between different applications and systems. On the key advantage of XML is its flexibility in representing data with nested structure while making it useful for storing and exchanging non-traditional data formats. XML is a markup language used to store and transport data. It uses tags to define elements and attributes to provide additional information about those elements. It is designed to be both human readable and machine readable, making it a popular choice for exchanging data between different systems. It is widely used in web services, which it provides a standard format for exchanging data between different applications and platforms. XML documents can be validated against a schema, which defines the rules and constraints for the structure and content of the document. Now we move to automation and database management. Automation and database management are two interrelated concepts in modern information technology. DBMS is a software system that allows users to define, create, maintain, and control access to the database. A database is a collection of data that is organized in a manner that allows for efficient retrieval, storage, and management. DBMS makes it easier for organizations to store and retrieve data, thereby reducing data redundancy, inconsistency, and improving data quality. Automation refers to the use of technology to perform tasks without human intervention. In the context of DBMS, automation can refer to automating tasks such as data entry, data backup, data recovery, and database monitoring. Automation can be used to enhance the functionality of a DBMS by reducing the time and effort required for manual tasks. The combination of automation and DBMS can help organizations to improve their efficiency, reduce error, and improve the accuracy of their data. Then comes augmented database. Augmented DBMS is a term which is used to describe the integration of artificial intelligence and machine learning technologies into traditional database management systems. Augmented DBMS combines the capabilities of DBMS with intelligent processing capabilities and capabilities of artificial intelligence and machine learning to create a more efficient and effective system for managing data. Key benefits of augmented DBMS is its ability to automate tasks that were previously done manually, such as optimizing query performance, detecting anomalies in data, and predicting potential issues with the database. Another benefit of augmented DBMS is that it can help organizations to better utilize their data. By analyzing data in real time, augmented DBMS can identify trends and insights that may have been missed with traditional database management systems. Augmented DBMS has the potential to revolutionize the way that organizations manage their data. By integrating artificial intelligence and machine learning into traditional database management systems, organizations can improve efficiency, reduce errors, and gain insights that were previously impossible to obtain. Some ways in which artificial intelligence and machine learning can be integrated into traditional database management systems. They are automated data entry. Artificial intelligence and machine learning algorithms can be used to automatically enter data into a database, reducing the risk of errors and improving efficiency. Secondly, predictive analytics. Machine learning algorithms can be used to analyze large volumes of data and make predictions about future trends and outcomes. Third one is fraud detection. Artificial intelligence and machine learning algorithms can be used to identify patterns and anomalies in data that may indicate fraud or other types of malicious activity. Fourthly, natural language processing. This is a technique which can be used to analyze unstructured data, such as customer feedback or social media posts, and extract valuable insights. Fifthly, recommendation system. Machine learning algorithms can be used to analyze customer behavior and make personalized recommendations for product or services. Integrating artificial intelligence and machine learning into traditional database management system can provide organizations with powerful tools for data analysis, automation, and decision making. In-memory database, what we call it as IMDBs. These are the type of databases management system that stores data in computer memory instead of on a hard drive or other storage device. In comparison with traditional disk-based databases, which must read and write data from the disk, IDBMS can access and process data much more quickly since data is already in the memory of the system. One of the key benefits of IMDBS is their speed, their ability to handle large amount of data. They can be more expensive than databases due to the cost of the memory. Graph database. A graph database is a type of NoSQL database that uses graph theory to store, query, and manage data. Graph databases represents our data as nodes and edges which connect the nodes. The nodes represent entities or objects with the edge represents relationship between these entities or objects. Graph database can provide significant benefits for applications that requires complex relationship-based data modeling and fast and efficient query. Open source database. An open source database is a database management system that is freely available to use, modify, and distribute under an open source license. This database provides users with the ability to view, modify, and enhance the source code of the database, making them more flexible and customizable than priority databases. Key benefits of open source database is its cost effectiveness. It also provides a high degree of flexibility and customization. They may not provide the same level of support and documentation as proprietary databases and may require more technical expertise to set up and maintain. This can be called as their disadvantage. Database as service. It is a cloud computing service model in which a third-party provider offers a database management system over the internet. This typically manages the installation, configuration, and maintenance of the database, allowing customers to focus on their data and applications instead of underlying infrastructure. Key benefit of DBR is its flexibility and scalability, which offers simplified database management. Since the database is hosted on the cloud, the customers may experience latency or network performance issues. Customers may have limited control over the database configuration and maintenance, which may be a concern for organizations with complex or specialized database requirements, while it may be suitable for all applications. DBAS can provide a valuable tool for organizations that require simplified and cost-effective database management. Now comes data mining. Data mining is a process of discovering patterns, relationships, and insight from a large set of structured and unstructured data. It involves extracting knowledge and useful information from large data sets using statistical and machine learning algorithms, as well as data visualization and other techniques. The goal of data mining is to extract valuable insights and knowledge from the data, which can be used to make informed business decisions, improve processes, and gain competitive advantage. Data mining techniques can be applied to a wide range of data sources, including transactional databases, customer data, social media data, and web data. Data mining techniques include classification, which involves grouping data into predefined categories based on specific criteria. Secondly, clustering. This involves grouping data into smaller similar categories based on similarity of features. Third one is regression analysis. This involves predicting a continuous variable based on the interrelation between other variables. Association rule mining. This involves discovering relationship between items in a dataset, such as products frequently purchased together. Fifth one is anomaly detection, which involves identifying unusual or unexpected pattern in the data. Data mining can be used in a variety of fields such as healthcare, finance, marketing, and social media analysis. However, data mining raises concern about the privacy and data protection, and organizations must take steps to protect sensitive information and ensure compliance with data privacy regulations. Now, we move to block 4, that is emerging technologies for business. And now we will start with Unit 10, that is cloud computing. We will start with the introduction to the cloud computing. This cloud computing refers to the delivery of computing services such as storage, processing, power, and software application over the internet. Cloud computing offers many benefits such as flexibility, scalability, and cost saving. It allows organizations to quickly scale up or down their computing resources as needed without having to invest in expensive hardware and software. This also enables collaboration and remote work, as users can access their applications and data from anywhere with an internet connection. It also presents challenges such as data security, vendor locking, and the need for reliable internet connectivity. Notice the history and how evolution of cloud computing started. The roots of cloud computing can be tracked back in 1960 with the development of nine sharing systems that allowed multiple users to access a single source, that is, a computer. This model evolved in 1990s with the introduction of application service providers, what we call it as ASPs, which provided access to business application over the internet. However, these early versions of cloud computing were limited to their capabilities and accessibility. With the modern era of cloud computing began in way back in 2000, mid of 2000, with the launch of Amazon Web Services. That is, in short, we call it as AWS in 2006. This AWS provided a platform for developers to build and deploy web applications without the need for physical infrastructure. This marked the beginning of infrastructure as a service model, which has since become a dominant part of the cloud computing landscape. In 2008, that is 2 years later, Google launched a cloud-based application suite, that is Google Apps, which provided businesses with email, word processing, and spreadsheet software accessible through a web browser. Many of us might be using it, and people are using it. This marks the beginning of software as a service model, which has since become a popular choice for businesses looking to reduce their software licensing and maintenance costs. In 2010, the platform as a service model was introduced with the launch of Hero, a cloud-based platform for deploying and managing web applications. PaaS provided developers with a platform for building and deploying applications without having to worry about the underlying infrastructure. Now, moving further, what are the different types of cloud? Cloud computing can be categorized into four main types based on their deployment model and ownership of infrastructure. First one is public cloud, second is private cloud, third is hybrid cloud, and the fourth one is multi-cloud. We will start with public cloud. Public cloud is a type of cloud computing in which the infrastructure is owned and operated by a third-party service provider. Thus, resources such as servers and storage are shared among multiple organizations, and users can access these resources over the internet. An example of public cloud providers include AWS, Microsoft Azure, and Google Cloud Platform. Secondly, private cloud. A private cloud is a type of cloud computing in which the infrastructure is owned and operated by a single organization. The resources are not shared with other organizations, and the cloud can be hosted either on premises or in a third party data resource center. Private clouds provide organizations with greater control over their infrastructure and data, and then can be customized to meet specific business needs. Third is hybrid cloud. A hybrid cloud is a combination of public and private cloud models, allowing organizations to leverage the benefits of both. Organizations can use the public cloud for non-sensitive data and applications, while keeping sensitive data and applications in a private cloud. Hybrid clouds provide organizations with greater flexibility and scalability, while also providing greater control over sensitive data. Fourth one is multi-cloud. A multi-cloud strategy involves using multiple cloud providers for different application of or workloads. This approach can provide organizations with greater flexibility and redundancy as well as ability to choose the best cloud provider for each specific need. However, managing multiple cloud providers can also present challenges in terms of integrity and security. What are the different cloud components? Cloud computing typically consists of several components that work together to deliver computing resources and services. These components can be categorized into three main layers. First one is infrastructure layer, second one is platform layer, and the third one is software layer. If we talk about infrastructure layer provides the basic building block of cloud computing, including servers, storage, networking, and virtualization technology. These resources can be used to build and deploy applications and services. Infrastructure as a service providers like Amazon Web Services, Microsoft Azure, and Google Cloud Platform offer these resources as a service, allowing organizations to provision and manage their own computing infrastructure. Second one is platform layer. Platform layer, this provides a platform for building and deploying applications without the need to manage underlying infrastructure. Platform as a service providers like YouTube, Google App Engine, and Microsoft Azure App Service offers a platform for developers to build, deploy, and manage their applications with built-in scalability and flexibility. Thirdly, software layer. This provides software application and services that can be accessed over the internet without the need to install and manage them on local devices. Software as a service, that is SaaS. This providers like Salesforce, Microsoft Office 365, and Google Cloud offer software applications that are hosted and managed by the providers, allowing users to access them for anywhere where they are with an internet connection. In addition to these layers, cloud computing also includes management and security components. Cloud management platforms provides tools for managing and monitoring cloud resources, while security as a service providers offer security services to protect data and applications in the cloud. Cloud computing infrastructure. We have been talking about the softwares. Now we will see what this infrastructure of cloud computing is all about. This refers to the physical and virtual components that makes up a cloud computing environment. These components are used to deliver cloud computing services, includes computing resources, storage, and networking capabilities. The infrastructure layer of cloud computing typically includes servers. Cloud providers use large number of servers to provide computing resources to their customers. These services are typically hosted in data centers and are managed and maintained by the cloud provider. Second one is storage. Here, cloud providers offer various types of storage options to their customers, including object storage, block storage, and file storage. These storage options can be accessed over the internet and can be used to store data and applications. Third one is networking. Cloud providers offer networking capabilities that enables customers to connect to their cloud resources over the internet. This includes virtual private networks, what we call it as VPNs, load balancers, and firewalls. Next one is virtualization. Here, providers use virtualization technology to create virtual machines, VMs, that can be used by customers to run their applications. Virtualization enables customers to use computing resources more efficiently by allowing multiple VMs to run on a single physical server. Then comes your management tools. Cloud providers offer management tools that enables customers to manage their cloud resources. These tools include dashboards, APIs, and command line interface that allows customers to provision and manage their cloud resources. What are the pros and cons of cloud computing? We will start with pros of cloud computing. No doubt it is cost saving. Cloud computing eliminates the use of businesses to invest in expensive hardware and software, which can have significant cost. Scalability. Cloud computing allows businesses to easily scale their resources up or down depending on their needs, which can help them in taking or adapting the changes in the market conditions and taking the decisions faster. Flexibility. Cloud computing allows employees to access data and applications from anywhere with an internet connection, making it easier for them to work remotely. Next one is reliability, and the last one is security. What are the disadvantages of cloud computing? Since we have been saying that internet connection is must, that means we have a dependence on internet. Cloud computing requires a reliable internet connection, and any disruption in this connection can result in downtime for the business. Data security concerns. While cloud providers often have strong security measures in place, businesses may still be concerned about the security of their data when it is stored in third-party servers. Limited control. Businesses may have limited control over the hardware and software used by the cloud providers, which can make it difficult to customize the environment to their needs. Then comes your compliance issues. Certain industry may be subject to strict compliance regulation, and using cloud computing may not be complement with these regulations. Now we can see what are the different cloud deployment models. In short, we can say we have heard all these things on premises, that is in-house operations, private cloud, virtual private cloud, and public cloud. We can see how What are the different properties which can be understood? It is the nature of the user, how users share their cloud instances, what is the nature of network accessibility, and what is the place of production of the model. Service management in cloud computing. Service management in cloud computing, this refers to the set of practices and tools used to manage and monitor the delivery of cloud-based services to end users, which involves a range of activities such as monitoring service availability and performance, ensuring security and compliance, managing user access, and handling incidents and service requests. Cloud service management can be divided into several key areas. We will start with service level management. This involves setting and monitoring service level agreements to ensure that services are delivered according to the agreed upon performance and availability standards. Secondly, incident management. This involves identifying, tracking, and resolving incidents that occur during the delivery of cloud-based services. Thirdly, change management. This involves managing changes to the cloud infrastructure, applications, and services to ensure that they are made in a controlled and coordinated manner. Configuration management. This involves maintaining a record of the configuration items that make up the cloud infrastructure and services and managing changes to those items. Then comes your security management, which involves ensuring that the cloud infrastructure and services are secure and compliant with relevant regulations and standards. Capacity management. This involves ensuring that there is a sufficient capacity in the cloud infrastructure to meet the demand for services. Here are some of the benefits of cloud management services. We'll start with robust infrastructure, specialized services, service level agreements are there, data safety and recovery, quick response time, interfacing, planned investment, maintenance, timely updates in the due course of time, and integrated services. These are the benefits of cloud management services. Now, what about data management in cloud computing? This refers to the process of storing, processing, and managing data in a cloud environment. This involves wide range of activities such as data migration, backup and recovery, data security, and data governance. What is data migration? This involves moving data from one premises storage to a cloud environment. This can be a complex process that requires careful planning and coordination to ensure that data is migrated efficiently and without disrupting to the business. Secondly, data backup and recovery. Cloud-based data backup and recovery services are typically used to ensure that data is protected against accidental or malicious data loss. This service provides automatic backups and point-in-time recovery options to help organizations quickly restore their data in case of an outbreak or disaster. Data security. Cloud typically offers a range of security services to help protect data in the cloud. These include encryption, identify and access management, and threat detection and response. Data governance. This involves managing the policies and procedures that governs the use of data in the cloud environment. This includes managing access controls, defining data retention policies, and ensuring compliance with regulatory requirements. Data analytics. Cloud computing provides us a powerful platform for processing and analyzing large amounts of data. Cloud-based data analytics services can help organizations gain insights into their data, identify trends, and make data-driven decisions. Now we will talk about resource management and security in cloud. Resource management and security are two critical aspects of cloud computing that ensures that cloud resources are utilized efficiently and securely. Effective resource management helps us to ensure that cloud-based applications and services are highly available and perform well. Why? Security service measures helps us to protect sensitive data and prevent unauthorized access. Some key aspects of resource management and security in cloud computing are: first one is resource management, which involves managing the allocation of resources such as virtual machines, storage, and network bandwidth to ensure that the application of services have the resources they need to operate effectively. In terms of security, cloud providers offer a range of security services to help protect cloud resources from unauthorized access, data loss, and other security threats. These services include identity and access management, network security, data encryption, and threat detection and response. Then comes your compliance. Cloud providers also help organizations meet regulatory and compliance requirements by providing compliance certification, auditing and reporting tools, and other compliance related services. Disaster recovery. This is an essential component of cloud security that involves preparing for and recovering from potential disasters such as natural disasters or cyber attacks. Monitoring and reporting. Cloud providers offer tools and services to help organizations monitor and report on their cloud resources performance and security. Effective resource management and security in cloud requires a combination of technology, process, and people. Then comes your inter-cloud resource management. This refers to the process of managing resources across multiple cloud environments, such as public, private, and hybrid clouds. It involves managing resources such as compute, storage, and network across different cloud providers and ensuring that they are utilized effectively. Some key aspects of inter-cloud resource management are resource allocation, means management, which involves allocating resources to applications and services across multiple cloud environments. Second one, load balancing. This is a critical aspect of inter-cloud resource management that involves distributing workloads across multiple cloud environments to ensure that resources are utilized effectively. Then comes your interoperability. Inter-cloud resource management requires interoperability between different cloud providers to enable seamless management of resources across multiple clouds. Security. Inter-cloud resource management requires robust security measures to protect data and resources across multiple cloud environments. cost management. Inter-cloud resource management requires effective cost management to ensure that resources are utilized efficiently across multiple cloud environments. Effective inter-cloud resource management requires a combination of technology, process, and people. Cloud providers offer a range of tools and services to help organizations manage their resources across multiple clouds effectively. Resource provisioning and resource provisioning methods. Resource provisioning in cloud computing refers to the process of allocating computing resources such as virtual machines, storage, and network bandwidth to support cloud-based applications and services. Resource provisioning can be done using several methods depending on the needs of the application or service provider. Some common resource provisioning methods are manual provisioning. In this method, administrators manually allocate resources to applications and services based on their requirements. This approach is suitable for small-scale deployment or applications with predictable resource requirement. It can be time-consuming and error-prone. Secondly, automated provisioning. This method involves automating the process of resource allocation using tools such as configuration management and orchestral tools. Automation enables faster and more reliable provisioning of resources and allows administrators to respond to changes in demand quickly. Then comes your on-demand provisioning. Here in this method, resources are allocated on demand as needed by the application or service. This approach is suitable for applications with unpredictable resource requirements or those with expertise, sudden spikes in demand. Then comes your dynamic provisioning. Here, this method involves dynamically adjusting resource allocations based on the change in demand. For example, additional virtual machines may be provisionized during peak demand periods and deprovisionized during low demand periods. Then comes your capacity provisioning. Capacity provisioning involves allocating resources to applications or services based on expected demand. This approach involves predicting future demands based on historical data and allocating resources accordingly. With this, we will be ending today's session.